Hey everyone, this is Mayur. Welcome back to ML Works. In this video, we'll try to understand how to apply certain techniques for language understanding. So what we'll do is, we have seen basic techniques in NLP like bag of words, using frequency of the words in a document to understand what the document is talking about. So, but what we'll do in this particular notebook is we'll try to use the embeddings of those documents and apply certain algorithms like nearest neighbor search, or we can apply large language models to get the topics from the keywords or from the clusters that is available once we apply other algorithms like k-means or nearest neighbor. So with that, what I'll do is I'll just jump on to the setup part where you need to install all these packages that are required and update certain packages if they are not compatible with these packages. Okay. So once that is done, we'll try to import all the packages that are required. So first go here, then NumPy, all this regex, OS, pandas, and dataset UMAP. All the other packages which are totally dependent on the kind of techniques you're trying to apply. So we need all these packages. Let me import all of them. So we have imported all, and now first thing is we have to download the data set. So we are downloading the data set which is in embedding format, which is NumPy array. So we are downloading that. Next, what we'll do is we'll also take the CSV file of that particular data set and use load it using pandas. And here we will be using the embeddings that are of the same data set in the embeddings format. So let me run this as well. So it has downloaded the data set, it has loaded the data frame as well. There are 3000 rows currently, and the embeddings is of size 3000 comma 1024. So each document is represented using 1024 floating point numbers and la vector. Okay. Now let's get the head of this particular data set. This two documents we'll look at. So we have columns like title, URL, text, dead, by, score, time. So all these are the some of the columns that represents a data set. So these are this particular what we see, right, title here is what is turned into a particular embedding. Okay. So what we'll do is next we'll just look at the embeddings as well. It is nothing but a floating point numbers. Now what we have is we have a data set in text format. We have a data set, the same data set in embeddings format. Now we'll try to build a search index where we apply each embedding with a specific index. So if we see here, we use annoy index embeds dot shape of one angular, and then apply each index here I to the specific index, specific embedding, and then we try to build the search index using this particular command dot build and dot save. So once that is done, we'll first apply first technique. We'll apply and see how we can understand certain aspects of our data set. So first what we are doing is, given an existing post title, retrieve the most similar post. So there are 3000 records. What we'll do here is we'll take one random record from 3000 records and we'll see if there is any other similar record present in the data set or not. So we have taken a sample record which is number 50, which is the index. You can consider it as an index 50, and we fetch corresponding title here. If you see here, we'll be fetching corresponding title. Now what we do is, if you see here also, okay, nx by item, we are passing the sample id 50 here, and then we are also getting the top 10 results out of it, and also including the distances which will represent how similar the record is with respect to the sample id. So this is just nearest neighbor search we are doing here, and let's run this thing. So if you see here, 50 sample ID 50 is nothing but pick startups for YC2 fund. It has few keywords. One is startup, that is YC, and its funding. Okay, and all the research results we got using the searching index is all related to mostly YC, founder, startups, and all the other keywords that are present in this particular query title. So this is one way to use search index and embedding nearest neighbor search to get a particular similar records based on a specific query. This is existing title we are using here. So what we'll do is next we'll go for a query where you type in a query, some random query, and we'll see if any of that particular query matches with any of the documents present in the dataset. So first what we'll do is first we'll be loading the API key for Cohere, and then let me run this. So then what we do is we send a query. What is artificial intelligence? This is our query. This will be sent to Cohere API, which is an embedding model, and it will generate a vector 1024 in dimension. Now that particular vector is compared against the search index. Okay, once that is done, we'll get top 10 results, and then that will be stored in a data frame. So what is artificial intelligence is our query, and let's see if we have any document or post related to this particular query. So we have what similar record, similar post related to artificial intelligence. So we have best books for AI, we have which algorithms based on biological ideas do you know, best way to get started with AI, ML, all these related to this particular topic. So let me go back to this particular cell where we are sending the query. We are sending it to co.embedding. Co.embedding is nothing but the Cohere client that we created here. We are just passing that query to here, and the model that needs to be used in Cohere, and the input type is it a search query, and then we are taking the embeddings out of it, and that will be the query embedding. And once we get that, then we'll be passing it to the search index. We'll fetch the top 10 results and include the distance as well. Once that is done, then we'll create the data frame where we pass in the text and the distance. That's it. That's what this particular data frame represents. Now what we have done is we have given an existing title, post title, and try to search similar records. We gave a query and try to search similar records. Now what we'll do is we'll try to project our embeddings onto a lower dimension space and try to understand how the posts are related to each other. So for that, what we'll do is first we'll import the packages of UMAP and pass the neighbor as 100. So this particular parameter, what it tells us how this particular cluster needs to be created in 2D dimension. So if you have large number of n neighbors, it means it will create a larger cluster. If you have small number of neighbors, it will create smaller clusters like 2 records or 4 records based on the n neighbors. Now what we do is first we create a reducer object which is umap.umap, and then that we apply it on the embeddings fit.transform. Now once that is done, we'll try to plot that particular embedding using using this chart what is called Altier, right? What we have used Altier library. We'll try to project that there. Let me just apply this. So here we have x and y. Okay, we had 1024 dimension. We pass that into 2 dimension now. Okay, x and y, and we have clusters of different documents. Now what we'll do is we'll just look at one specific cluster here, because we have it nicely placed in here. See, who is hiring, all these documents are related to hiring, so they all are grouped together with a different time stamp. This is one cluster. Let me go to any other cluster. Here we have, it is freelancing, related to freelancing, all these particular data points. So you can understand, right, the bunch of topics that are related, that are present in this particular data set are combined in such a format using this particular clusters. Now what we'll do is we'll try to cluster these things and give them labels to it. Okay, give them labels to it. So first what we have is just, let's print the embeddings. Now what we do is we have UMAP applied, but we did not assign any class to it. Okay, since we can, though we can see the clusters, but we are not assigning any class to that particular data set directly. So what we do next is we give some randomly give some cluster number here 8, and then we initialize the k-means model, and then we apply this k-means model on top of the embeddings. Now it is what it is, fit underscore predict. So what it will do is it will try to assign a number which is the class to each of the embeddings. So since there are totally 8 class, so based on the near k-means clustering algorithm that is applied, it will try to cluster the records which are similar to each other and give the same class label to each of them, which are similar to each other. Now what we have done is we have applied, we got the classes as well for the each embedding. Now what we'll do is we'll try to create, extract the keywords from each cluster and try to use that in the next step. So let's get to these steps. First, what we do is we have a data frame and we just take it out, df.title, we take it out, and then we pass the documents to again a new data frame, pd.dataframe document is equal to documents, and then we create a index. The topic is not given to each of the document, but since we have predicted here the class for each embedding, what we'll do is whatever we have predicted here, we'll pass that as the topic. That classes what we have generated here will be our label for each of the document. Okay, so once that is done, then we do something called as, based on that particular topics or the class labels that we have given, we try to group them and try to combine all the all the documents related to a particular class, all are combined together. So that's what is happening here. We are aggregating the documents here. So each class will have one document. So if I just let me run this first. What I'll do is I'll just show what documents per topic looks like. So if you see here, there will be 8 documents in total, and all the documents represent one class. Okay, this represents one class, and if I could see here, 0 is it, yeah, topic 0, topic 0, this is topic 1. This, all these combined together formed one particular, formed, all these documents are combined together and mapped to a particular class. So let me just comment this out. So let me go back. So here what we have done is we created a one whole, all the documents are combined together to form one document per class, and then we apply count vectorizer, which is turning the text into something called as bag of words kind of thing, and then we are applying fit and transform. These two steps can be done in one. Okay, fit transform, and then we get the features out of this particular vectorizer, and we'll get the names or words out of this particular vectorizer. Then we apply classic class tfidf. Okay, this is specific to what, identifying keywords, okay, in your particular document based on the cluster that you have created. Okay, so here what we have done is, overall we have all the similar documents are combined together and mapped it to a particular class number. Now we are applying on top of that, we are applying this tfidf transformer. This will help us to get the keywords out of it. And then what we do is, then we create a label is equal to a bunch of keywords. Here we are taking around 10 keywords based on the org sort. Now let me just df.cluster is equal to classes, and then we have keywords is equal to, so once we words per class we have, right? So based on that we'll also have keywords per cluster as well. So that also is formed here. Let me run this. So we have executed this already. Let me just run df. Let me run cluster. So give us this detail, and then let me also add in something called as keywords. So what we can understand from this is, this particular cluster has these keywords present often. This class, same keywords. For this class, same keywords. So here we are taking the top 10 keywords for each of this particular class or cluster. So words is nothing but what we have got from here, right? Count vectorizer, what is the keyword feature names out. That is the words. Documents is again, let me run this again. Okay. So if you see here, what is the document, what is the corresponding topic it belongs to. For example, this is belonging to a book recommendation or something like that. best resource on leadership, and again, if you see best books you read in the past decade. So they all belong to one particular topic. Okay, and this is best alternative to this belongs to topic number 6. If I just give 14, let's see. So here we have one which is again on blog, and why should I read it? And then this is also again to blogs, and this is again to books. This is also again books related. And if I look at this, how did and urgent connection support? This is password related. All this looks similar to it. So this is the document corresponding topic we got. Now what we'll do is we'll try to understand how this cluster is created, right? Using k-means, we'll try to visualize that. This will give us better understanding actually. So as I shown, words per class. So this is one cluster, 0 is one cluster, and what is the keyword in that cluster is this one. This is another cluster, corresponding keywords. This is another cluster, corresponding keywords, and so on. Now comes the visualization part. Again, we'll use Alt and we'll just apply these particular clusters that we have created. So it looks amazing. So we have 8 clusters. So we can see yellow color one cluster, oranges is spread across a range, green is one cluster, red is one cluster, and this blue is another cluster. So let me look at one specific cluster. So let's go to the blue one first. So this is talking about hiring again. All these are related to hiring. Okay, all these blue clusters. Hiring, hired, who wants to be hired. Okay, and then let me go to green cluster then. So it talks about salaries, project, how to earn money, passive income. Okay, all these are one specific topic. Let me go to the red one, and if we look at here, it is about courses, I guess. Courses, paid course, public speaking course. Okay, okay. So all these are related. Okay, these all these clusters are quite related. Now what we'll do is we'll apply the keywords that we got from here. We'll apply to some generative language model. In this case, we'll use Cohere, and we'll try to understand what topic it basically talks about. All these keywords. Okay, so it's already applied once, and we can apply it again. So what is, if you look at some of the keywords that we saw earlier here, so it was applied, and what we got the result was the common theme for the following keywords is that they all relate to the favorite books to read. Okay, that makes sense. The common theme for the following keywords are startup, company, YC field. They all relate to startup companies and their failures. And the common theme of the following keywords again relate to hiring for a freelancer to join the team or of a startup. So these are something, yeah, we can do. So if you want to, if you pass this particular thing, right, the common theme of the following, and take one of the keyword from the cluster and pass it to the or generative language model, will get the output as something similar to this one. So this is one of the thing here. This is a chart here which represents like how these keywords are related, which are close to each other. These two topics are quite close to each other. And if you compare this first line, which is open source web code software, with the respect to what last one, there is a maximum distance among these. Okay, but if you see this open source web code, all these again with the third one, which is self courses design good best programming. So these are related. So the distance between the green line is quite less when compared to green line with the blue line, because the distance between those particular topics are quite large. Now, as I said, what we'll do is we have the cluster, we have corresponding keywords. Now we'll pass those keywords to a language model. Okay, and then we'll see how that language model gets the output. So here again, I'm using cohere.chat, which is Cohere is the client which will interact with the large language model in the backend. So message is what is the theme for these keywords. So I'm taking one particular cluster, picking their keywords and getting that particular bunch of keywords and sending it to this particular model and fetching the text. That is the response. If I just hit that, so let me also pick it out. this particular what is this particular cluster is all about. So this cluster is about advice, developers, skills, interview, tech, engineer, programmer, developer, job, software. So this is related to what? Everything related to software, interview, all the aspects of engineering, software engineering skills. So the what the model has generated, the keywords provided revolve around the theme of technology and software development. It totally makes sense. The term advice one second. The term advice, interview, job skill especially point towards the process of preparing for and navigating the world of tech jobs. The focus on developers, engineer, programmer, and software further emphasize that this theme is about skills and experience related to the role, and it is about the technical abilities and know-how required to succeed in the field. Companies hiring for these roles often look for technical proficiencies, real-world experience. So the keywords could be related to preparation to the technical interview, each technical interview land the desired job in the tech sector. So the model was able to generate the whole picture of all the documents that is present in the data set, and it has conclusively said what it is, all the keywords are related to by pointing out each keyword. Okay, so it is much more efficient when compared to uh, other basic techniques that we use for language understanding. Okay. So with this, what we have seen is we have seen 6 techniques that you can use to understand your language data set. So with that, what I'll do is I'll just conclude this video. Thank you so much.